We're asked to solve the system of equations for x, y, and z. X plus 2y plus z equals 3, 2x minus y plus 2z equals 6, 3x plus y minus z equals 5. The general strategy on this is we're going to start by getting an equation and eliminate one of the variables. It doesn't matter which one. I'm just going to say get an equation with no z. Our second step will be to do it again. Will be to get another equation with no z. Now it doesn't matter whether you eliminate z or y or x, just make sure you get rid of the same variable on these first two equations. Now once you have those, we're going to use those two equations. So we're going to use the equations that we just found, and we're going to eliminate another variable. So let's say we eliminate y. Now we know what x is. Once you know x, we're going to plug that x value into one of the equations with no z. So we're going to either plug it into 1 or 2. At this point, now we know y. Once you know x and y, we're going to plug the x and the y into one of the originals. One of the original three equations. And at this point, now we know z. So this is a fairly involved process. Let's see how that goes for this problem. I'm going to start by getting an equation with no z. The easiest way to do this would be to take equations 1 and 3 and add them together. So x plus 2y plus z equals 3. I'm just copying them down for now. And then 3x plus y minus z equals 5. And now we add these together. If we add them up, I see the z's cancel out. So we combine the x's, we've got 4x. Combine the y's, we've got 3y. And on the right-hand side, we have 8. So this is the first step. We got an equation with no z. Next up, we've got to repeat that process. We've got to get another equation with no z. So what I'll do here is maybe add equation 2 and equation 3 together, because I see one has a positive and one has a negative. But in order to do this, we're going to have to multiply the second equation by 2. So that way the positive 2z and the negative 2z will cancel. Let's see this in action. I'm going to copy the first two equations first. So 2x minus y plus 2z equals 6. The second equation is 3x plus y minus z equals 5. Since I want the z's to cancel, I'm going to make these coefficients, I'm going to force them to be the same by multiplying the second equation by 2. If we rewrite this, we now have 2x minus y plus 2z equals 6. And our second equation is now 6x plus 2y minus 2z equals 10. Now when we add these together, the z's cancel. That's what we wanted. So we're left with 8x plus y equals 16. Now we've done step 2. Next up, our third step is to use the equations we just found to eliminate y. So I'm going to copy them down first. 4x plus 3y equals 8. That was our equation number 1 from step 1. And then from step 2, we've got 8x plus y equals 16. And now to eliminate y, what I'm going to do is multiply the second equation by negative 3. This way, the positive 3y and the negative 3y will cancel. So this leaves us with 4x plus 3y equals 8 for the first equation. The second equation, we've got negative 24x minus 3y equals negative 48. If we add these together, the y's cancel. If we combine like terms, we have negative 20x on the left-hand side equals negative 40 on the right-hand side. Now we divide both sides by negative 20. So we've got x by itself, and on the right-hand side, we have 2. So x equals 2. This is step 3. We've found our x value. If you look at the next step in the procedure, we're going to plug that x value into either equation number 1 that we found or equation number 2. Since we're going to be solving for y, I want to plug it in here because y has no coefficient. So I'm going to take 8x plus y equals 16, and I'm going to plug in the x value we just found. So this is 8 times our x value, so 8 times 2, plus y equals 16. So if we simplify, we've got 16 plus y equals 16. Then we subtract 16 from both sides of the equation. They all cancel and we get y equals 0. So that is step 4. We have an x value, we have a y value. So finally, step 5 is to plug the x and y values into one of the original equations to get z. So if we go back up a little bit, the first equation had no coefficient on z. That's the one I want to use. So I'm going to copy that down here. X plus 2y plus z equals 3. And I'm going to fill in the values that we've identified. We know that x is 2. So instead of x, we've got 2 plus 2 times y, and the y value is 0, plus z equals 3. We go and simplify, so we've got 2 plus 0 plus z equals 3. Next up, we'll subtract 2 from both sides to get z by itself. So on the left-hand side, they cancel and we're left with just z. On the right, we combine those together to get z equals 1, and that was step 5. We've now identified x and y and z. The only thing left to do is present our answer as a point. It's got to have coordinates x and y and z. So our final solution will be 2, 0, 1.